Before there were calculators, you had to use these books of log tables to approximate the value of a log. So if you wanted to find, say, log base 10 of 1.221, 1 and 21 hundredths, you would need to make sure you were on the log base 10 table and then find log of 1 is here, log of 1.21 would be here. So you would have to look up what the value is before calculators. And if you wanted to find log base 11 of 1.21, that would be on a different page. You'd have to go to a whole different chart of log base 11. It's much easier with calculators. We will use Desmos.com. Log base 10 is called the common log because it appears so frequently. We see it and use it a lot. So if you don't see a log number, that means the invisible base number is 10. So you don't need to write that in. You should just know that it's there. Log of 4 or log base 10 of 4. So here's how you'll put that in the calculator. You want to get Desmos.com, graphing calculator. You'll need to open up this keyboard and go to functions, miscellaneous, and log. We're finding log of 4 and estimating to 2 places after the decimal. So we want 0.60 is our approximation. So make sure you use the wavy approximately equal to 0.60. Done. Let's find the other ones. Maybe pause the video and write down what decimals you get, because that way when I write it, you can check if your rounding is correct. Log of 0.3. Negative 0.52. Negative 0.52. Log of 7. Log of 7. 0.85 if we're rounding. Approximately equal to 0.85. Last one, log of 0.5. Log under miscellaneous functions, negative 0.30, approximately equal to negative 0.30. Done. So check that you have those correct, rounding and everything, and let's keep going. Now let's practice switching forms. You want to remember it is first, last, middle. First, last, middle. So the only reason we're practicing this is it doesn't look like there's a first number. There's just a middle number X and a last number Y. So you just remember that the first number is the invisible base number 10. Write it if it helps you. And then do first, last, middle. 10 to the Y equals X. Next one, same thing. Write the 10 if it helps you. If you can just think that part in your head, that's fine. First, last, middle. Done. All we're doing here is switching forms. First, last, middle. Done. Write the invisible 10. Be careful with this one. First, last, middle, and that's done. So we're just practicing how to do first, last, middle, and not forget that there's an invisible 10 we use as our first number. So how can we use logs to help us? This type of equation, this exponential equation, you already learned how to solve this, is you hedge to get the same thing on both sides. But you can't hedge 19, so you're stuck. The old method we learned doesn't work for this. So this is actually really easy to do. Watch this trick. You're going to take the log of both sides, because remember before if we had log on both sides we canceled it. Now we're just going in the opposite direction of that. There's no log on both sides, and we're adding one in. You take the log of both sides because here's the genius. The power property says your exponent can jump out front. So we have x times log of 4 equals log of 19. Almost done. I know it doesn't look pretty, but at least these problems are easy to do. How do I stop x from multiplying by log 4? Divide log 4 on both sides. So it cancels, and we have x is approximately, now we have to put that in the calculator. So log 19 divided by log 4. You can't just divide 19 by 4, it won't be the same. You can't cancel out the logs top and bottom. So log 19 over log 4, let's find it. Back to Desmos. I'm going to get rid of some of these old functions. So we need log of 19, I'm going to close those parentheses, divided by a new log of 4, close parentheses, just to be safe. So we have 2.12, because we're still rounding to the hundredth place, 2.12. So this is helpful because we couldn't hedge the 19, but we still got a fairly accurate answer. That's done. Let's do 2 more of these. I would pause the video and do problem B on your own, because that's a good way to find out if there's something you're not understanding. Step 1, take the log of both sides. Step 2, power property jumps the x out front. X times log of 3 equals log of 15. Step 3, divide that log 3 out of there. So we have x is approximately, and now we put it in the calculator. If you put 5, you're totally wrong. You can't just divide the 15 by 3. Log 15 divided by log 3. Let's find it. Log 15 divided by log 3. .46. 2.46. So we can see how it's definitely not the same as 15 divided by 3, which would be 5. Next one, same thing. I would pause, do it yourself, and then check to see if you have any mistakes. Step 1, take the log of both sides. Log of 6 to the x equals log of 42. Step 2, power property jumps the x exponent out front. X times log 6 equals log 42. I don't know why I wrote 43. Step 3, divide the log 6 out of there. Divide log 6, divide log 6. X is approximately, now we put that in the calculator, log 42 divided by log 6. Log 42 divided by log 6. .08, and the 6 makes us round, so it's 2.09. 2.09. And done. So normally you would hedge, but the hedging doesn't give us the same thing on both sides. Like a problem that you would not need this is something like 3 to the x equals 9. You could hedge the 9 and then have 3's on both sides. Can't do that for these types of problems though. All right, last thing. The change of base formula allows you to write equivalent log expressions with different bases. So we just know how to do log base 10 calculations on the calculator, but what if I give you log base 11 of something? especially in the days when you had to use the log tables. If you didn't have the page of log base 11, then you just couldn't find it unless you knew this formula. So if I have something not helpful, like log base 11 of 2, you can change it into whatever kind of log you want, and we always want log base 10 because it's the common log and it's easy to find and use. You would just change it into log base 10 of 2. My box got all shifted around, so the rectangle should be 2 and the oval should be 11. Log base 10 of 2 over log base 10 of 11. I'll rewrite it for clarity. Log base 10 of 11. And then you just put it in the calculator. And remember, you don't need to write the 10 because it's implied if you don't write anything at all. Log 2 divided by log 11. So then you just put that in the calculator. I won't do that one. Let's just get these ones. So step 1, I can't do log 3. I can do log base 10 and that's it. So you write log base 10 of 3. Nope, that's wrong. Top number goes top, bottom number goes bottom, over log base 10 of 3. It helps me think about it because the 20 is slightly higher than where the 3 is, and the 20 is higher than the 3 when you do the change of base formula. So also I think the base goes down in the basement on the bottom of the fraction. Everything starts with a B. Let's find it. Log 20 divided by log 3 in the calculator. Functions, log 20 divided by functions, log 3. So it's 2.72, and the 6 makes us round it to 2.73. This is approximately 2.73. It's important to have the wavy equal sign. If you put a regular equal sign, it's actually incorrect. I probably wouldn't count off for it, but no promises. Problem B, same thing. You write log base 10 of 8 over log base 10 of 6. I did it correctly, first try. So we'll put that in the calculator. The base 6 goes down in the basement on the bottom of the fraction. Log 8 divided by log 6. So we get 1.16. 1.16. Approximately equal to. Done. And that's it. This is one of my favorite formulas because it's super easy to use.